Okay, discriminant up next. Question 10, I think this is. Given that this quadratic equation, k minus 1x squared plus 2kx plus 7k minus 4 equals 0 has no real roots, show that this exists. Now, this will come quite organically from the first part of the question. Then we have to find out what k is. So it's just a quadratic solving inequality to end the question, but I have to show that this is the case first. And by the way, if you can't show that this is the case, we can still do the final bit of the question because they give it to us. It's one of these lovely questions. So no real roots. If an equation has no real roots, that means that b squared minus 4ac, the discriminant, is less than 0. There's your starting point. I have a quadratic equation here where a is x minus 1, k minus 1, b is 2k, and c is 7k minus 4. I'm going to sub them in, and I will end up with an inequality. And if I rearrange and simplify that inequality, I will end up with this. So, probably going to be quite a difficult one to expand and rearrange. I'm going to take this quite slowly. So we have 2k in for b squared. Take away 4 times a, which is k minus 1, times 7k minus 4 for c, is less than 0. So simplifying some of that. This all squared, don't forget to square the 2 as well, to give you 4k squared. Take away 4 times. Now, I'm going to expand just the double brackets, and I'll deal with that minus 4 in a moment. So just the double brackets. K times 7k, 7k squared. Minus 1, k times minus 4 is minus 4k. Let's write that up there. Minus 4k. And minus 1 times 7k is minus 7k. And then minus 1 times minus 4 is a positive 4. These two will simplify to give you minus 11k in the middle. So just get rid of that now. Is less than 0. Okay, I'm going to expand that second bracket. So we end up with 4k squared minus 28k squared minus 4 times minus 11 is plus 44k. Minus 4 times 4 is minus 16. It's less than 0. So I can simplify some of this. I end up with minus 24k squared plus 44k. Take away 16 is less than 0. Now, that is not quite what I was supposed to end up with here. It will get there, but it's not the same yet, because I can simplify this. I can divide through by something. Now, 4 will go into everything here, but they have a positive k squared, and there's currently a negative k squared. So if I divide through by minus 4, that will help me out, because I will end up with positive 6k squared minus 11k plus 4, and whenever you divide or multiply the inequality by a negative number, that switches the sign. So we're going to switch that sign to a positive, and we do end up with what we were supposed to. Now I'm going to go up here to finish the question. So if I want to find the range of values of k satisfying this inequality, it's just solving, but there's a little bit of a difference at the end. So it's 6 times 4 is 24, and I want a pair of numbers that adds together to give me minus 11. Minus 8 and minus 3 works out nicely there. So if I split it, it's 6k squared at the start, plus 4 at the end, split down the middle. I'm going to put minus 3k and minus 8k in those positions. 3k brackets 2k minus 1, minus 4 brackets 2k minus 1 works out nicely. So we have 3k minus 4, 2k minus 1, but don't forget that the inequality we had was that it was greater than 0. So we end up with, if I was to rearrange these, we have k equals 4 over 3 and k equals a half, but they are not the solutions. Those are my critical values. This is where we need to consult the graph. And on this graph, these two critical values of a half and 4 over 3, let's say, are those two positions there. My quadratic of 6k squared, etc., is something that looks, a little bit like that. And I want it when that is greater than 0. So these two separate portions of the graph line are greater than 0. We draw an imaginary vertical line, those two positions there. This portion here is to the left of a half, which means that k is less than a half. This portion over here is to the right of 4 over 3. So my second inequality is k is greater than 4 over 3. It can't be greater than equal to or less than equal to because that inequality didn't exist in the first place.